We are all familiar with the Dyson vacuum cleaners, which come along with several different cleaning heads. We have one head specified for vacuuming the sofa and another one for the floor. So we have one device vacuuming different surfaces using different heads. This is exactly the idea behind creating a generic plugin system. Hello, my name is Chen. I love to travel, go to the beach, and work out a lot, as you can see in the picture. I'm a front-end developer at Minute Media. I'm currently part of the core team, but before I was part of the CMS team. CMS is a content management system, a software application that enables users to create, edit, publish, and store digital content. When we want to create and share information, ideas, and news virtually, we use social media. Posting attractive visual content and videos make content much more interesting and engaging. For example, what a better way to talk about the new bizarre Netflix show than sharing the trailer and expose it to whoever familiar with it. As you can see, the trailer in this article is an embedded YouTube content. In order to do that, we need to add to our CMS the ability to embed content. We started by connecting our system to YouTube by creating an embedded YouTube component. Afterward, we decided to add Instagram to our store system. So we created an Instagram embedded component by doing the same thing we did when we created the YouTube component. Then we also had Twitter, so we needed to do it all over again. At this point, we realized our system will continue to grow with more embedded components. The result is code duplication. We decided to create a generic plugin system, a system that allows the growth of the product for future need with minimum effort, providing extensibility and flexibility. So how do we start to create a generic plugin system? First of all, understanding the system flow. Every plugin has the same general flow. The user inserts the relevant URL. Then we get the embedded data from the plugin server and process the data to a preview block. Once the user approves, content will be shown on the article page. Secondly, we need to choose the format that will support various of the plugin features. In our case, we choose the OEmbed format. And then we choose 2 to 3 cases and compare between them to understand what is similar and what is different. If we take, for example, YouTube and Instagram, there are a few similar things. Getting the URL from the user and checking if it's valid, fetching the relevant data, process the data by running some script, creating the preview data block, show an iframe in HTML. The differences are the server that we are fetching the data from, the data structure that is returned from the server, and the script that are required for processing the data. The final step is designing the system. At this point, we need to stop and think which feature should be implemented as part of our generic solution and which should be developed as a standalone solution. The plugin system consists of 2 components, a core plugin system and the plugin component. We are creating the plugin component according to the similarity and differences we saw before. Let's take a look at the UI system. We can see that we have one system that contains all the plugins. Clicking on one of them will take us to the relevant plugin component. We will create a generic plugin component that has the URL input, the preview block, and the add button. Here you can see, for example, the preview block for Instagram and YouTube. The component will receive from the outside what is different for each plugin. In addition, the component will take care of common code being used by multiple plugins to avoid code duplication. In our case, when there is a server error, all the plugins will show the same error message. In this case, you can see we are passing YouTube data to our plugin component to create a plugin instance. And this is what each plugin needs to do. After the plugin component implement is done, we need to implement our core plugin system. This system will host all the plugins and will be in charge of rendering the selected plugin component. Each one needs to register itself to the system. The way to do it is by adding the plugin type and its render function to the core system. Now, every time we want to add a new plugin, all we need to do is just send the relevant data to the plugin component and register it to the core system. Although generic systems have many advantages, we need to make sure we are not over-engineering the system. So how much generic is too generic? The resultant code becomes much more messy and complex than it should be. The code doesn't add stability or improve maintainability. The system includes very unlikely scenarios. You should not take into consideration a possible need if you don't know about. When a system becomes too large, besides having a negative impact on the performance, the system typically becomes more complicated to use. The system API will be more extensive. This requires more knowledge of the developer who is using the system and make debugging harder as more things can go wrong. Developing and debugging the system itself become harder as one needs to account for more and more edge cases. We need to remember not to add specific implementation to our generic solution. If it doesn't fit, don't try to force it. For example, let's take the URL prop for the plugin component. We decided the URL validation should be done inside of the plugin component, based on the idea that every URL has the same basic validation. Facebook decided that their URL cannot end with a number. To support these changes, we added the if end with num flag to the component interface. Now, we need to add another URL validation in case this flag is true. Then, Instagram decided that their URL must include the word Instagram. So now, we will add another flag called should contain Instagram. We can see that our validation functions start getting big and complicated. We started by checking the basic validation. Then, we check if the two conditions are happening, and if so, we check their validation. If both of the cases don't happen, we need to check only the relevant ones. We can see that we have a lot of if statements that we need to check, and on top of that, they are irrelevant to all other plugins. We can understand that in this case, it is better to send a URL validation function from each plugin to the component, and the component will run it when needed. Today, this plugin system allows us to add a plugin in minimum effort, providing extensibility and flexibility. At any given point, we can add, remove, and change existing plugins with minimum or even not at all effect on the rest of the core system or other plugins. In addition, the process of adding new plugin is almost effortless. To summarize, there are several cases when we will need this generic design. Increase the efficiency of the code when we have a lot of code duplication in our system. When we are designing a system composed of many components which may interact with each other, the system should be dynamically extended to include new plugins. Since the plugin ideally provide a well-defined interface and documentation for plugin writers, developers have a clear roadmap for development. For my personal experience, the plugin system helps us to handle complexity, simplify application configuration, and deployment. It may have taken us longer to develop at first, but it saved us a lot of time in the long run, so it was worth it. Hope that you enjoy my presentation, and next time when you want to implement a plugin system, it will help you. For any more questions, feel free to reach out. Thanks.